Welcome, everyone, again to another episode of Disruption Drives. Today, I welcome Cameron Gieda. Cameron is currently head of business development at Fort Robotics, where he continues his lifelong passion for helping the most innovative companies solve the biggest problems of our time. Just some of his achievements range from introducing the world's first digital video microscope at Keyence Corp to catalyzing Factory 2.0 with smart sensors. Today, at Fort Robotics, he's at the forefront of autonomous vehicle safety. Clearly, the most impactful technological shift of our time, and a great promise for saving human lives. He led the charge at Pony AI, Velodyne, and autonomous stuff. Cameron knows a thing or two about true disruption and how to bring it to early adopters, which makes him a perfect guest for the show. Cameron, welcome again. Thank you so much for taking the time. I wanted to start with sort of a broad question. Look, autonomous vehicles in general, one of the good things about it that there seems to be a sort of an asymptotic goal here, which is human safety. But in
Mhm.
just very layman terms, I mean, considering that is the core promise, what should a human being consider safe?
And this is the question of our time, I guess, Hari, where we want the same thing that a human can do in a vehicle, but we want that delivered by a robot. And but interestingly, the measure of that safety isn't very high if we think about the safety of riding in an Uber or a taxi or even a city bus. They crash at a much higher frequency than we would expect autonomous vehicles to do. And and I think you combine that with this sort of bar that's been set for autonomy of zero accidents. And many other large automotive companies have the same idea of vision zero, right? Of at least aspirationally trying to look for a point in time where people aren't killed in transportation systems, whether that's private or public or whatever. So so safety is, I guess, somewhat abstract in this case where everybody has a different idea. And I think at the end of the day, it's how safe does someone quote unquote feel? Because it's very subjective. And I think you got to kind of imagine what makes you feel safe. And is that the company's transparency? Is it the fact that it's Google or it's Elon Musk or their safety record? And ultimately, us in this industry are very familiar with how many miles Waymo has driven autonomously or what happened with this cruise accident. But I'm here in downtown LA. I can guarantee that 80% of the people using Waymo don't know about any of that stuff. And for them, safety is all about that experience of dealing with the car comes to get me, the car drops me off, and how does this thing feel whilst I'm in it? And does it make me feel safe?
Absolutely.
Yeah. So I think over the years in dealing with these systems, the first demos are very conservative. Vehicles scared to really go very fast, but now Pony AI's vehicles and Waymo's vehicles, they drive just like people, maybe even with a little more assertiveness. And that assertiveness is sort of interpreted as safety because it feels like it's confident. So this comes down to motion tuning to get it to quote unquote feel like a human. So as we grow closer to the robot, there's this interesting evolution to make it feel like a driver is driving it.
You bring up some interesting points, which is look, obviously there's functional there's the objective safety requirement of okay, do you keep
Mhm.
people's well, just kill fewer people the more miles you drive. But the
Yes.
passenger, on the other hand, is literally not prioritizing safety per se, but what they feel as safety, which is really convenience and comfort, which is how quickly does it pick it up, how clean is the car,
Yeah,
does it talk to them when they don't want to, or those sort of things.
precisely. Precisely.
And tell me a little bit about how do when it looks like you're of course focused on safety,
Mhm.
but this is an intangible benefit for customers, looks like. And in reality,
Yep.
it feels like how do you convince an early customer to prioritize safety rather than these tangible benefits of what he said, comfort and convenience and quick moving and so
Th that has to be done through, I think, transparent communications, right? So w all of this is trust. right? We're putting our lives in the hands of these systems that are run by private companies. And there has to be some clear level of communication from Waymo or whoever is going to deploy this business. I'll keep riffing on Waymo because they're the only here in the West fully deployed systems. Um, and working in California, you can see how many issues they've had over their entire scope of development, if you're interested in that. And
Absolutely.
and of course, the anything that happens is magnified in media because there's a lot of Schadenfreude, I think, around this industry of like, ooh, the autonomous car did this or that. Um, so I think the first thing in terms of safety is you need transparency, you need regulatory approval. State regulatory approval brings kind of a stamp of safety of a third party that has doesn't have skin in the game, but is basically making sure that I'm safe. So if I know that the DMV and the CPUC, the California Public Utilities Commission, have signed off on this as safe, I can be confident that it's not going to hurt me. So that's sort of the baseline for trust. And companies that try to walk around that, like Tesla's trying to do, they say, "Oh, we have a permit, but it's really just a permit for normal taxi livery." That doesn't breed trust. If there's any questions around, do they really deserve a permit? Did they do the testing? That's going to start punching holes in that veil.
But to your point, you've also mentioned the average passenger doesn't really know what they look at it. To what
Yeah.
extent is there sort of adoption? It's a new car, novelty, versus
Mhm.
it actually feels better as a ride.
Yeah. Interesting. I think that's where the bar is a little lower.
Yeah,
Um, so there's a lot of nuance to how, if you've ridden it in an Uber or a cab, all of those people drive differently. Some are aggressive, some are less aggressive. You never know what you're going to get. Um, and then, and then, of course, a Waymo or any automated system is going to feel exactly the same every time you ride in it. So that level of consistency, delivery of product, right? It's like when I go to a nice restaurant and I have my favorite dish and I go back there a month later, I sure as heck want the exact same thing to taste the exact same way
right.
for what I'm paying for. And I think these systems delivering that extreme consistency is a huge bonus over a normal human-driven system.
Absolutely, Barry.
And then you can expect that, right? It's like I know if I leave to the airport, I'm in LA, it's going to take me X amount of time, depending on traffic.
Absolutely.
Um, so I think delivery consistency of delivery is really important for that trust equation.
Talking about trust, right? One of the things, of course, you currently work on is you're, of course, the early mover on autonomy has been industrial automation.
Mhm.
And it's likely that the tangible benefits of safety for compliance reasons and insurance reasons are a bit more easily sellable as well. Of course, then
Mhm.
rather than the intangible, than the
Yep,
tangible benefits of comfort because industrial doesn't care.
definitely.
Is that a fair? Are we ahead on AV safety for industrial automation than for passengers? How is this different? Let's say goods, even good, because
Yeah,
including goods in a package delivery as industrials, part of
yeah,
yeah, road, yeah.
definitely. Well, we are not, and I'll give you
That's an
a,
interesting point. I
a,
would have expected you to say yes, but fair enough.
yeah. So Josh Butler, a good friend of mine who runs a company called Comp Science, which delivers workman's comp insurance based on observations of forklifts in factories. Are they going too fast? Are they running into each other? This sort of stuff. They're doing video analytics and over months, and they can kind of deliver a risk value to which then they provide insurance, and then those insurance rates might go up and down depending on what they're observing. So in general, within industrial fields, there is about a market of about 6 to 7 billion for safety stuff, sensors and systems and light curtains and e-stops. The safety infrastructure is about a $7 billion market. The workman's comp and liability market is about 600 billion, right? So that's all the money's paid for people getting hurt on the job or injured or trucks crashing, whatever. So it's 100x difference. So you
Wow.
can So there's very little invested in prevention, and there's an enormous amount invested in the result of not having the right level of safety. So there's still this enormous sea change that I believe needs to happen to even if correct get those numbers a little closer to each
Yeah.
other with more safety controls. Because at the end of the day, and I talk about forklifts. Forklifts are the largest insurance liability in any factory, and they're big, heavy. They run into each other. They run into the infrastructure within factories kind of regularly. And they don't have ADAS suites on them. They don't have active safety. So today you could argue that a Waymo is safer than working in a factory.
Well, fair enough.
Yeah.
But why is that though? The fact that, look, I would have assumed that for in
Mm.
all fairness, I mean, these are nasty looking machines, pardon.
Yep.
But this is an industry that has existed fundamentally, has always had, OSHA requirements and
Yep.
safety has been a priority. But looks like
W-
we're actually not. We're really focused on post
Yeah.
post care.
Well,
Um,
we are, and I think there's distinct focus on certain parts of safety in factories. And you brought up machine guarding or machine safety, wherein I have a metal stamping machine or something. And I can put a light curtain around that and I can protect people from getting hurt by it. Really at the point of use. But I think, and typically that's where automation is applied around a specific machine and a specific operation. Um, and there's a distinct focus there because that's where it can be applied. It's repeatable and there's a confined space. But the thing we haven't focused on is mobility within inside the factory. There's a few automated guided carts and things running around, but the bulk of material handling, whether that's in logistics or in manufacturing, is all happening with human-driven forklifts.
Interesting.
And so I have a fixed space. It's easy for me to protect that, my welding cell or an assembly cell, with hard guards or lidar. But as soon as I pick up that work piece with a forklift and start moving it around, the risk margin goes up 100-fold because I'm just driving around the factory without
Yeah, just
any safety systems.
interesting synopsis of what you said was, look, so you're safe when you stand and do one thing,
Yes.
but once you start moving, we haven't really invested in that safety.
And if you extrapolate that out to like the road, it's the same thing. It's like a fixed system like a train is very safe, but as soon as I start driving down the road,
Yeah,
you introduce all sorts of risks via the long tail of things that can potentially happen whilst in motion.
absolutely. Switching gears a little bit, I wanted to talk because safety also includes online safety. And one of the things that
Mhm.
ABC has been criticized for is, and I know you work on with Ford Robotics as well, one of the
Yep.
promises is preventing cyber attacks. And of course, as we more make basically a car a digital system, how
Hmm.
credible do you think this problem is and how do we prevent it? Because there's also a sort of pushback saying, look, these autonomous vehicle robots are effectively on-premise software
Yeah.
with not too much
Mhm.
cyber attack problems, but of course can have bugs. But
Mhm.
specifically, tell me a bit about how do we prevent is that a big problem enough that and how are you solving that?
So, but most of these systems up till today have been designed to work as islands, as you mentioned, right? So, and coming from Pony AI, the system is designed to withstand a cellular dropouts or GNSS. Like if I'm no longer getting GPS signals, I'm utilizing a SLAM algorithm where I'm using the lidar and other sensors to localize. So because of the inconsistencies of, I guess, infrastructure, these systems were always used in a way that, or I guess designed in a way that you basically depend on it not working very well. And in and of that, that leaves you less vulnerable to somebody somehow affects the cellular signal or somebody somehow affects in a nefarious way, the GPS signal. We've built these systems to withstand that because in the US especially, you just can't, your cell phone doesn't work everywhere. And if you're getting some GPS functionality from it, that doesn't make for a good safety case. So, but that makes the systems much more expensive, right? And then you kind of start affecting the economics of it when you have a very expensive GPS and an IMU and multiple LiDAR that are doing localization as well as detections, which then creates more computational workload just to understand where the car is, for instance. Um, and that's basically I guess the whole picture. And we've yet to see the point where we've seen this in movies where suddenly the vehicles become sentient and start driving themselves down the road in some crazy
Transformers
way.
too. Transformers, huh?
Exactly,
Possible
exactly.
Transformers.
The whole apocalyptic movie when the Teslas are somehow driving themselves down the freeway. Um, we're not there yet, I should say. And I think controlling the vehicle to really do something specific, the only way I could imagine doing that now is via teleoperations.
Yeah, yeah, yeah,
And teleops do introduce, I think, a certain level of risk because you're putting a human back in the loop
yeah.
with that potentially spotty communications network. And honestly, I think having a human in loop potentially driving the thing is maybe the most risky part of autonomy. And I that relates directly to what Tesla's doing right now in Texas. Having humans doing a good amount of the work is a very risky proposition.
But that's actually one of the things that you're actually working on today at Fort Robotics. You have a human in the loop, sort of with a joystick controller managing fleets.
Absolutely.
And so tell me about this. I mean, where does the human in the loop need to remain? Well, you've said it that it is
Mhm.
it is a more risky proposition.
Yep.
Uh, but is this going to really be the future for drivers?
It isn't. It isn't. And I'll kind of I'll segue a little bit into the evolution of Fort and what we do.
Yeah.
Um, so at our core, Fort is a big red button that can stop a robot. And if you've seen this video of this Unitree robot that was vibe coded, using very basic coding techniques to make it dance, and it didn't dance, it was almost killed somebody. But nobody had conceived, well, geez, maybe I want to have a way to stop this thing if it starts going crazy. And that's what Fort provides is a functionally safe interface to any robot over wireless to stop a vehicle. And we have a ton of cybersecurity involved in there in a black channel that's doing that communication, so nobody else can kind of get on that signal and stop it or control it, God forbid. And a heartbeat going between these two signals, so we know that it's connected. If that heartbeat is lost, the robot's going to time out and stop automatically. This is typically used with a person on it, but of course, the evolution is to have a person not be involved and have some sort of autonomy or signal to do that. So, and I'll explain how that would work. So, I've got my fleet of automated fork trucks or something running around a factory. And there's some observer that might need to maintain them or get up near them. And in this case, they can select the robot they want to stop, take it off autonomous mode with the controller, stop it, and do whatever they might need to do. And obviously, that's a very human, time consuming thing. The next evolution of that is I want to be able to walk into this area where these robots are operating and I don't want them to run over me. So as I open the door, there's a sensor there that then signals to the robots a human has entered, everybody slow down or stop in the area so this person can safely walk through. Very much a binary solution. Door opens, robots stop, humans can enter. And I'll give you a funny example around this. There's a factory in the UK that's using automated fork trucks and they have very little safety system because they're like, we're just going to block off the area where they're working, and there's no humans in there, and they can do as they want, no worries. Which is great. You get great efficiencies. You just got to make sure people stay out of that area, and you're good to go. So a fire happens in the factory, and they call the fire department. The factory's on fire. Come on over, put it out. The firemen get there and there's like, we're not going in there. Those forklifts are running around and we have no way to control them. They could kill us.
A
And they're like, we're not going inside. And of course, the end result is the place burns to the ground
lot of pit
because they
bulls.
had exactly. You had no way to stop these vehicles.
Fair enough.
Um, so that's a critical piece. But and then extrapolate that further. So I enter a door, robot shut down. Now I want to start going further. I want those robots to keep moving, right? I want to fully utilize my assets. I want them running as fast as they possibly can safely. So this is the jump to out what we call outside in safety. I want to use AI from a fixed position. This is the smart factory idea that we talk about smart factories and smart cities, but we've seen very little of these ideas manifest in real life. And this is one of those wherein the factory has cameras or LiDAR, like the Eye of Sauron, that can see unoccluded every area of the floor in the factory. And through data fusion techniques, combine all of those into a single frame so I can see everybody moving, where everybody is. I can track them, identify them, and potentially steer them so they don't run into each other. And the first big benefit you get there that safety has never done is identify things, right? So a safety system like a light curtain or a safety lidar doesn't know if it's a box or a person or a forklift or a unicorn, right? It
Yeah,
just detects something and it shuts off. That isn't efficient, And then, but if I can, apply this outside in idea where I can watch everyone, I'm using techniques drawn directly from autonomous driving, like tracking and prediction. I'm tracking something. I know how fast it's going, its trajectory. I know where it's going to be in a few seconds.
right.
I'm tracking another agent. I know where those, and I know it's going to collide.
Yeah,
If I have the way to effectively stop those things, which Fort provides, we can wirelessly and safely stop something or slow something down before a collision. And if AI can make that inference from a fixed position, I don't need a bunch of sensors on my robots anymore.
very fair. So using the laws of physics
Yeah.
more than we're using AI, of course.
Well, a little AI. I mean, we're doing motion planning and everything, right? We would have borrowed from autonomous driving, but we are using AI to infer, is it a forklift or is it a person? And
Great.
knowing that those two things are gonna behave differently, and we need to protect one from the other.
Absolutely. Well, Cameron, that's again, you're when things get too expensive, just rely on the laws of physics. Is probably what we'll summarize this all as. But
Yes.
Cameron Gieda, once again, everyone wanted to thank you for your time for this. This is all we have, but we should be doing many more conversations like this, and especially focused on your vast experience and of course everything disruptive and new market entry for this. There's very few people in the world who I think I could call on to talk so intelligently about this topic. So thank you, Cameron.
Thanks so much, Hari. It's my pleasure.